Hey everyone, welcome back to Take You Forward. So today we will be doing the last problem on DP on strings, and it's a wonderful problem, wildcard matching. So what does this problem state? The problem states you'll be given couple of strings as usual, and in those strings, yes, in those strings you will be having a star, like you will have characters, but you can have a question mark or you could have a star. Okay, now question mark means matches with single character. Remember this, it means matches with single character. Star means matches with sequence of length 0 or more. Okay, so what does this mean? Let me give you a couple of examples. Assume the string 1 to be question mark ay. Okay, and remember one thing, this question mark or the star will only be in the string s1. It will not be in the string s2. So the string s2 is ray. Okay, now let's see if they match. Y matches, A matches. This R is with question mark, and it states question mark means it matches with single character. It can match with any single character. So I can say question mark matches with R. So all of these three guys are matching. Thereby, this S1 is matching with the text S2. Thereby, you need to return a true. Since they are matching, you need to return a true. Let me take one more example in order to explain the star portion. So assume the string S1 to be AB star CD. Okay, and assume the S2 to be ABDEFCD. Okay, now I need to figure out, are they matching? Okay, star means it can match any, yes, it can match any sequence. So let's take it. D matches with D, C matches with C, A matches with A, B matches with B. So I can say this star matches with the entire sequence DEF because it states matches with the sequence of length 0 or more. So this star matches with this DEF. What if? So this is definitely true. What if I change the strings and I say, what if the string would have been star star and something like ABCD? Okay, and the string s2 is something like ABCD. Are they matching? And the answer to that is yes, they are matching. Why? Because D matches with D, C matches with C, B matches with B, A matches with A. Now these star, I can say a single star is a length 0. So this is matching with a length 0. This star is also matching with length 0. So hypothetically ABCD is equal to ABCD. Star means it can match with someone or it cannot match with someone. The string can be of any length. It can be of a length 0, it can be of length 1, it can be of length 2, it can be of length 3, and so on. So let me take one more example which is false. String s1 is AB question mark D. String s2 is ABCC. Okay, let's see if they are matching. A matches with A, B matches with B. Question mark can only match with one. So question mark matches with C, but this D is not matching with C. Thereby, this is false. You will say they do not match. So this is the question. Given a string S1, which will definitely, which can or cannot have, like it will have lowercase letters for sure. It can have a question mark and it can have a star as well. Given a string s2 which will just have lowercase letters, you need to tell me if the string s1 matches with the string s2 or not. You just need to return me either a true or you just need to return me either a false. You just need to make sure you return either of these. So how do you actually proceed with this problem? So in order to think, I can say the first thinking that will come to my brain is, hey Striver, string matching, simple string matching. Question mark is bound to match with R. So the first thing that comes to my brain is simple string matching. And we have already done simple string matching in the previous DP problems. So, fine. Where is the main problem? The main problem arises, yes, the main problem arises if it is a star. Because for question mark, it's very straightforward, they will match. But for star is when the problem arises. So let us take an example and understand. Assume you had AB star CD, you had AB, D, E, F, CD. So when you're matching, you'll be like D matches with D, C matches with C. But for the star, you exactly don't know how many will match, because you know B matches with B. But for the star, you have to be very critical whether you'll take this F, whether you'll take EF, whether you'll take DEF, whether you'll take BDF, or whether you'll take A. So for a star, you can be like, I will not take anyone and I'll start matching B with F. Or you can be like, for a star, I'll take F and then I'll start matching with B and E. Or you can be like, for the star, I'll take EF and I'll match B with D. Or you can be like, for the star, I will take DEF and then I'll match BB and then AA, and it comes out to be true. So you without trying, you cannot say that you will be taking 3. You have to try by taking 0, by taking 1, by taking 2, by taking 3, by taking 4. You have to try always. Like for star, you don't take, then you're taking 1, then you're taking 2, then 3, and in 3 it matched, so you moved across. You have to try all possible ways, and whenever a question comes across all possible ways, what comes to your brain? Definitely recursion. I will try recursion. String matching by recursion is what I will try. I will try out every possible portion. Perfect. So rules to write the recursion. Come on, it's very simple now. What are the rules? If there are 2 strings, you express them in terms of I and J in order to compare. Try comparing, like explore comparisons. Third, out of all comparisons, it is asking you, can you or can you not? So out of all comparisons, if anyone can, or if any way can, you return true, because that is how you solve true and false. If you remember the lecture 6 of the recursion series, I have told you, whenever there is a problem which has to return a true or false, the standard pattern is very straightforward. You write an F and this, in the base case, you either return a true or you either return a false. If there are multiple states, if this returns true and if this returns false, you will return true if you are looking for one true. If both of them return false, you return false. That's what you do in true and false recurrences. You try out all ways. This is one way, this is one way, and you basically say, okay, what are you returning? And on that basis, you do something, right? So, out of all comparisons, if anyone can, you return true, correct? So, how do you actually solve this problem? So, let's analyze f of ij. But we need to figure out what is f of ij. Let's see. I'll be like, what if I write n minus 1 and m minus 1? What does this signify? This signifies nothing but if the string is AB star CD and the length is nothing but 0, 1, 2, 3, 4. So f of 4 comma AB DEF CD 0, 1, 2, 3, 4, 5, 6. This means in the string from 0 to 4, in the string 0 to 6, are they matching? Are these two strings matching? Is the string 1 from 0 to 4 matching with string 2, 0 to 6? This is what this function signifies, and it's going to return yes or no. I hope that makes sense. So going across, we will be writing the base case afterwards. So assume your I initially stands over here and the J initially stands over here. So what are you thinking? what can be the case? You are like, okay, they are matching. So if they're matching, it's very straightforward. The string gets reduced to this and this. Or what if there was a question mark? Then the question mark would have matched with D. Either both the characters match, either both the characters match because it's very straightforward. Either both of them will match, or you will be like, hey, listen, if it's a question mark, then also they will match. So I can say, whenever we did string matching problems, what conditions we had? One was the match condition, one was the not match condition. So for the match condition, we have two conditions over here. What are these two conditions? You can be like, if S of 1 of I matches with S of 2 of J, that's definitely one of the conditions. And the other condition is, if this is equal to question mark, then also I can say question mark does match with anything on S2 of J, which is, this is not and, this will be or. If either of these cases are true, they are matching. And if they are matching, can I say, I will be very, very humble to return f of I minus 1 because they are matching. So I shrink the string and I shrink the other string as well. Very straightforward. We have been doing the match condition right from the beginning of all the strings, right from the beginning of DP on strings. So very, very simple. We say these two are matching. Let's reduce our I, let's reduce our J and look for the smaller strings if they can be matched or not. We solved, this was the bigger problem. We solved a portion of it and we are asking the smaller portion to be solved by the recursion. Okay, so that's what this will be doing. Return. Okay, what can be the other condition? Let's analyze. The other condition that I can think of is, what if my I, let's erase this I over here, let's erase this J over here, okay? What if my I stands here? What if my J stands here? So what I see is, we have a star. Yes, we have a star. And I clearly said, a star means, you can say this did not match with anything. Like you can say for star means empty. So one of the cases that I can think of is, you will say star means empty and you'll be like, let's just shrink this AB and let's have the string. I'll say star means nothing. Now star means nothing. Or I can say this F matches with this star. Star means one character. And let's reduce this to ABDE. Which means J will go here and this gets reduced. I'm still standing at I. Okay, that can be one of the cases. Or I can say, let's match EF. Let's still stand at I. So I can actually match 0. I can actually match 1. I can actually match 2. I can actually match 3. I can actually match 4. I can match any number of characters for the star. Yes, any number of characters for the star. So I can either go that way. Or probably I'll try to write a recursion so that that way is also taken care of easily. Can I write? Let's see if I can write. So one thing is for sure. I will always take the case where I'll say, hey, listen, this star means nothing. Nothing. So I'll reduce this. And this will be AB and this will still be ABDF. That's one of the cases for sure. Where I say star means nothing. Star means nothing. So I'll be like, okay, if S of 1 of I is equal to star, I'll be like, let's assume it means nothing. Which means I will go and J will still be there because I said this star is equal to nothing because 0 length was allowed. Thereby, this gets omitted and I am with AB and I am still matching with this. Perfect. Okay, what can be the other thing? I need to check for a length of 1. I need to check for a length of 2. I also need to check for a length of 3 and so on. How will I manage that? Either I write a for loop. Either I write a for loop where I say I'll take F, then I'll take FE, then I'll take FED, then I'll take FEDB for the star. That may be one of the ways. So can I do this in this straightforward recursion? I can. Let me show you how. Assume let me write this recursion over here. Assume you are at AB start, okay? And this was AB, no, what was it? I forgot. ABDEF, yeah. ABDEF. Perfect. So I'm saying this star, hey listen, this star, you are no one. So I'm calling a branch where I'm saying, okay, go to this and go to, and now start comparing. So which automatically mean I meant nothing, nothing. So start comparing with BF. I did it. And the other thing that I can say is, hey listen, AB star, BH star, and move this string to here, which means I said I compared F. I compared F. So means I took one comparison. So I came over to here. Again, this is a string. And I'll again do the same thing. I'll say, hey, listen, the star means nothing. The star means nothing. So it will come to AB, ABDE. I said star means nothing. So it automatically came to AB, ABDE, which means you stated star to be just F. You stated star to be just F. How did you do that? You first said, okay, star means 1F. Let's reduce. Let's reduce. Then you said star means nothing. 1F and nothing equal to 1F. Equal to 1F. Right? Now I needed DEF. How will I do that? I'll again do the same thing. I'll say this star, let's match it with this E. So I'll go to another case where I'll be like, okay, I'll still stand at star. I'll move to ABD. Now this means first you matched with F, then you matched with E. So ABDE. So EF got matched. Thereby you are with ABD. Now if you say star means nothing, then you'll come across to AB and ABD. And you will eventually start matching with BD, which means you ended up eliminating F and E via this path. How? Delete F, delete E, then take start to be null. So you eventually came up to here. Or you can be like, hey listen, for the star I'm going to delete D. Fine. So if you delete D, you'll be like AB star, let's delete D. So AB. Perfect. So what you did now was you deleted F, you deleted E, now you deleted D. So eventually you deleted 3 characters for a star. After deleting 3 characters, you are saying, hey listen, there is no one. There is no one for the star. So you're standing with AB and AB, and eventually they will match. So you'll be like, okay, A and A, eventually they will match. So you'll be like empty and empty. So you tried out all patterns. See, you said 0, you said single F, which is this, single F deleted, you said delete EF, it went up and deleted F and E, so this was EF deleted, then you said delete DEF, so this was DEF. We did it using a single recursion. And how did we do it? Let's analyze every step. When we started, we said just delete this. So this is nothing but I can say I minus 1 and let's stay at J, isn't it? We are saying let's delete star, which is I minus 1, let's stay at F. So that's the one stuff that you're doing. That is the one stuff that you're doing. What are you doing over here? You're still standing here, but you're deleting F, which means you're still standing at I, but you're deleting F. So these are the 2 functions that you're doing. These are the 2 functions that you're doing. Yes. Perfect. That's how we can easily do this. So I'll be like, okay, either this or I am going to delete the other one. Either the empty, I'll take it as empty, or I'll just delete one character, and the next step it will again delete one character, and the next step it will again delete one character, so eventually 1, 1, 1, all set of characters like 0, 1, 2, 3, 4 will be taken care in case of deletions. Perfect. What if the string did not match, or it is not a star? What if you are standing at a case where you are somewhere like assume A, B, C, A, E, C. So this C and this C will match. Then you are at B, E. This is neither a star, this is not a star, nor a question mark. So this is not matching. You cannot match them. So at the end of the day, if either the strings have to be matching, it has to be question mark, or it has to be a star. Otherwise, you cannot match. And if you cannot match, let's return a true. Perfect. Returned a true. Amazing. So that's how I have explored comparisons expressed as well. Out of all comparison, if any one of is true, which is this case, if any one of them is true, you return them. Otherwise, you return, I'm extremely sorry, this will be false. Perfect. What's the last step that you have to do? You have to write the base case. Let's analyze the base case. What will be the base case? We have to actually think. We have to think out of the box over here. What will be the base case? We have to think. There is no other way. So I know base case has to return true or false. And I know one thing for sure. I return true if comparisons have been done. So whenever you're doing string comparisons, in the previous class I told you there are two methods. What are the two methods? Either the string 1 gets exhausted, either the string 1 gets exhausted, or the string 2 gets exhausted. So let's think if the string s1 gets exhausted, what will happen? So this basically means my I pointer will go beyond 0. This means string gets exhausted, right? If this gets beyond 0, which means the s1 has no more characters left. And in order to match with s2, this also has to have no more characters. So can I say if I is lesser than 0, then the other string would have to be exhausted as well for the comparison to be true. Make sense? Make sense? Both of them have to be exhausted in order to the comparison to be successful. Perfect. What about if this gets exhausted? When you're comparing, what if your S2 gets exhausted? You need to think about that. So before going to string 2 gets exhausted, if this is the case, it's fine. Or if just the string got exhausted, if just the string got exhausted and the other string did not get exhausted, which means the j is still greater than equal to 0. So there are some comparisons still left, so return false. But there can be the other way where I say, hey listen, the j is lesser than 0, which means the second string got exhausted. It got exhausted. But on string s1, you still have something. What will be this case? You'll be like, Struggle, let's return false. No. What does this mean? The string 2 is nothing. It is an empty string now. What about this? The string 1 still has something. It might have something. When can it match with an empty string? When can a string s1 which has something match with an empty string? Think out of your box. If this has all stars, if this guy has all stars, because stars can only be represented by empty. If it has anything as a character, it cannot be. So I can say if s1 is left, it has to be all stars, it has to be all asterisks, otherwise it's not possible. So I can say for, you just need to loop from 0 whatever it is, 0 to I, and if anyone is not star, rather, you return false. Otherwise at the end of the day you have to return true, right? So that's what the base cases will be. Let's go back and try to write the base cases. Very straightforward. I said if both of them got exhausted, then the comparison has been successful. I said, hey, listen, if this is exhausted and J is still remaining, that means there are still comparisons from the string S to remaining, but you don't have anything to compare. So you're like, okay, return false. And the other case is definitely when this string got exhausted, but there is still I left, So I can, in a better way, I can write it as and there is still I left. These are the cases. Both gets exhausted. One gets exhausted, one does not. The one gets exhausted and the one does not. So in this case, you need to run a for loop and you need to check. I'll show you that in the code. So that's how you can definitely write the recursion. Correct. I'll write that in the code. But before that, let me just quickly walk you through the time complexity. Obviously, it's recursion. So you're going to try out all matchings and it is definitely going to be exponential. Again, you're doing with asterisk, so there can be 0, 1, 2. So the time complexity will be exponential. That is what I can say. Space complexity will be the stack auxiliary stack space, which is again somewhere around n plus m if you're doing the matching. So we have to figure out if there are overlapping subproblems. If there are overlapping subproblems, then you end up doing memoization. And how do you do memoization? Very simple. What are the changing parameters? I, j. What is the maximum possible value of I? N minus 1. So an n cross m dp is what you require. And you can memorize, and the time complexity after memoization will reduce to bgo of n into m, because those many will be the number of different states, and the space complexity will be n into m plus bgo of n plus m, which is the auxiliary stack space. So without actually wasting any time, let's get back into coding this and let's try submitting this. So we are given a string pattern and a text, right? So n will be pattern.text, m will be text.size, and we can return f of n minus 1, m minus 1, and we can pass on the pattern and the text. Perfect. And right here we can quickly write int f, int I, int j, string pattern, string text. And I know if both of them have exhausted, we can definitely return a true. I know if this string exhausted and there is still some matchings to be left, this is definitely never possible. And I know if the other string exhausted, which is s2, and there is still some portion of the pattern left, then all of those pattern, yes, what I can say is probably you can just run a loop from 0 till I. All of those guys have to be, yes, in the pattern, have to be equal to asterisk. If they're not equal to asterisk, you can directly return a false. And if all of these are equal to asterisk, you can just return a true. That's how you'll do. Or the other cases, you can set the pattern of I matches with the text of j, or if the pattern of I is equal to question mark, then it's fine, and you can directly return an f of I minus 1 because they are matching, and a pattern and a text. Perfect. What can be the other case? If the pattern of I is an asterisk, if it's an asterisk, you know there can be two ways. Either I say I'm going to go empty, which is I minus 1 and j, and the pattern and text, or you can say, okay, listen, I will not be going empty. Yes, I will not be going empty, and I'll just take away one guy, but I'll still stay at the same place. In the next step, I'll go empty, but I'll still stay at the same. So I'll still stay at the same for I, but I'll delete one guy. That's perfect. And that's how you can easily do. Perfect. And this is what you'll return. And if none of these cases exist, I know you're going to return a false because they are not going to match. Amazing. I think this should be perfect. So that's how you can easily do it. And now if I try to run this, this should be running fine. Indeed, it does run fine. We have to actually convert this into a dynamic programming. So let's quickly do this into a dynamic programming, which is dp of n cross vector of int. Again, you can definitely write m cross -1. That's what you have written. Okay, looks like we just need to declare this right above this. And please make sure you pass on the dp. And over here, just make sure you carry on the dp as well. And right before returning every time, you just, before calling other functions, if this state has been previously called, kindly return the value stored over there. Over here, rightly store the value. Over here again, rightly store the value before returning. Over here again, rightly store the value before returning. So if you just do this, it should be fine. Okay, we need to make sure dp is passed every time we call it. Please make sure you do that. Looks like the vector has not been declared, so please make sure you declare hash include bits slash std plus c++.h. We are getting a 100% score. That is indeed amazing, but you know, I'm not a big fan of memoization because it has auxiliary stack space, isn't it? So no, I don't want this. So we need to convert this into tabulation, right? Let's go across and super quickly write this. What are the rules of tabulation? I think now, after so many lectures, this should be in your head. Rule number 1, write the base cases. Rule number 2, write the changing parameters. Rule number 3, copy the recurrence. Rule number 4 is return whatever call you made. That's it. Base case is something, once you have done this, these are just plain. Okay, what is the base case? Let's go back into the code. So if you see in the code, you're doing I lesser than 0 again. So do you remember in all the previous matching of strings, like if you haven't seen them, please go back and watch it. In all the previous lectures, what did we do in order to make sure that it does not goes into negative? Yes, we converted this into a 1 based indexing. So kindly do this into a 1 based indexing, which is +1. Guys, this dp series is an extension of all the problems. Like if I'm teaching now, I'm assuming you have seen all the previous videos. So if you have not seen the previous videos, you'll not be able to catch it what I'm doing over here. So this is what you'll do. And again, this is the case. Again, this will be the case. Again, this will be the case. And this will be simply greater than 0 because you have done 1 based indexing. Over here it will be equal to 0, and instead of greater than equal to, it will be just this. And what about here? You are traversing. Yes, that's a 1 based indexing. So you have to traverse from one crater. Yes, you have to traverse from one crater, and you have to just go across doing till I. Correct? You are doing for 1 based indexing. So you will be traversing for one crater. Correct? Now, whenever you are at I, what will you do? You're looking for one lesser. So just make sure you look for one lesser. And if you do this, you are done. And what about here? You look for one lesser. What about here? Look for one lesser. What about here? You look for one lesser because 1 based indexing, guys. And right over here, again, one lesser. I think this should be fine. So you see it is giving correct answers, but I'll not submit this. And make sure you do it n+1, n+1. Perfect. So that's how you convert this into a 1 based indexing. Now what am I saying? I equal to 0, j equal to 0, right? And that has to be returned true. So let's convert this case into tabulation. So I'll just go over here and I'll say, okay, this will be 0, this will be false, or you can be like boolean. Perfect. And what I'll be like is, okay, I know dp of 0, 0 is true. That's what we have written. I equal to 0, j equal to 0 has to be true. And now for every I equal to 0, and whenever j is greater than 0, for every I equal to 0, whenever j is greater than 0, very important, whenever the j is greater than 0, so whenever j is greater than 0, which means 1 lesser than equal to m and j++, and dp of I is 0, and for this you have to write a false. Perfect. Is that what you write? Because for every I equal to 0, whenever j is greater than 0, you just make sure it's a false. So I just made sure I write it. What is the next case? For any j equal to 0, let's read this. For any j equal to 0, For any I greater than 0, you have to actually check this figure out. So for any I greater than 0, let's write this. For any I greater than 0, which means this, definitely. And what is j? J is 0. You will have to check for this. There is no other way. You will have to check for this. So just go across and you say, I am going to check for this. And if this is the case, yes, and if this is the case, we are straight away, yes, we will do nothing but we will say, hey, listen, dp of, what was I? I was 0. If you remember, j was 0. So go across and say, dp of this particular I and this particular j, which is 0, is going to be false, right? dp of this particular I and this particular j is going to be false. And if this is happening as false, or probably you can just keep a flag as true in order to have a better one, and you can just keep the flag as false, and then you can just break out, and right over here you come across, dp of j was 0, and for any I which was greater than, you can say whatever value of flag you get. If you get any time false, you store it, and if this false never appears, you just store the true. That's what I've done. For every j equal to 0, I greater than 0. For every j equal to 0, I greater than 0. You have done this. Now what about the changing parameters? Very simple. What are the changing parameters? Definitely this. And you do it in the opposite fashion. I've been doing this from ages now. Do this. Next, go across and copy paste everything in the recurrence. Amazing. This time be very careful about one thing, guys. You're writing if, so please make sure, because now return will not be there, so the following statements will be executed, or else. Okay, so just make sure you have something like else if, because the following statements will be executed. So over here, what will be it? dp of I minus 1, j minus 1. Perfect. So write it. dp of I minus 1 and j minus 1. Amazing. Over here, dp of I minus 1 and j. dp of I minus 1 and j, or dp of I and j minus 1. Perfect. That's what you will write. And you can just omit this portion. That's how you'll convert this line easily. And this will be normally false. And right over here, you can easily return dp of nm, and I think this should be fine. Let's quickly run this off. Okay, we got no matching call for the function. Are we still calling the function? Let's see. Okay, so we did a mistake. This will be boolean. My bad. Flag was not declared in the scope. Let's quickly check this off. Okay, boolean flag was declared here, then flag was false, then you did a break. Okay, line number 16, not declared in the scope. Okay, this was FL. Sorry, my bad again. Fine, runs fine. Let's quickly submit this. It does run. Wow, amazing. Now, can we space optimize this? We can. We definitely can space optimize this. Why? Because again, you're dependent on I minus 1, which is the previous guy, and you're dependent on I minus 1, again the previous and the current guys. So you can definitely space optimize this. But what are the problems that you'll face? First problem that you'll face is you have to declare the base cases. So it will become a bit tricky. So if you have solved the problem till here, I'll recommend you to try the space optimization by yourself. And if you don't, I'll explain the space optimization now, but if you don't understand, there's nothing to worry. With time, probably try it out by yourself, you'll understand. But the key to using space optimization is, if you're using the previous rows, then you definitely can space optimize. So let's come back and try to do the space optimization. So I know one thing for sure. Yes, I know one thing for sure, that instead of this, I will now be requiring one previous of m plus 1 false and one cur of m plus 1 false. Okay, so I know this previous is nothing but the 0th. Let's understand, it is the 0th row, and this is the first row. So on the 0th row, which means the previous. without any doubt. The zeroth row means the previous. Okay, amazing. 0, previous. I equal to 1. So what are you doing is, you are doing this for every row. For every row, you are saying, for every row, see, for every row, you are assigning the first column or the 0th column value. For every row, you're assigning the 0th column's value. So can I say, every time you go across to I equal to 0, the cur is the current rows column, and that cur's 0th row has to be assigned every time. Do you agree? Because over here you ended up assigning every row, like whatever row you had, you assigned by this. But this time you're starting with only 2. So you will have, every time you are at cur, you have to take care of this. Then the next time, whenever you go to the cur, you again have to assign this. Next time, again you have to assign this. So at every junction you have to assign. So I know this is the row. So this row is already running. So just make sure before starting off, assign it. Before starting off, assign the cur every time. For every row, just make sure you assign the cur every time. And then you can easily start off by saying, okay, this is what the previous will be. This is what the previous will be. This is the cur over here. And this is definitely going to be the cur. This is definitely going to be the cur. Right? And this is going to be the cur. And right at the end, you can say previous will be equal to cur. And over here, you can say previous or cur, whatever you wish to. And now you can run. Wow. Wow. That is amazing. The space optimization. I'm definitely sure you enjoyed the space optimization. Wow. We are getting 100%. So, guys, go step by step when you do space optimization. I know it's a bit tricky. It's a bit tough. But I'll always recommend try to do on pen and paper. Try to see what base cases you're writing. I went step by step and I converted it. I did not do a lot of things. I just went step by step and I converted it. So I'm using couple of 1D arrays and again an n cross m loop. So guys, I hope you understood the recursion which we started off. The memoization you understood. If you understood these two things, you're pretty much comfortable. And then we wrote the tabulation. Then we did the space optimization. So just in case you understood the whole package and the entire DP on strings, because this is where we wrap up on DP on strings. And I hope I was able to explain you all the DP on string problems. Not sure how, but let me know in the comment section if you're now comfortable enough with DP on strings and you can solve all the problems. So guys, just in case you loved this video, please give it a thumbs up. And if you're new to this channel, please do consider subscribing to us. And yeah, with this, I'll be wrapping up this video. Let's meet in the next one. Till then, bye-bye. Take care.